Also, good morning, good afternoon, everyone, and sorry for that quick interruption. Hopefully, it will work later. I'm based in London, hence, connection might be a bit difficult for me. Thanks, Iman, for this very nice words. Thanks, all of you, to be joining this panel today. It's a great pleasure for me to be here. Today, I'm joined by an exceptional panel composed of very senior leaders from AXA XL and from AXA XL partners. I'll ask them to introduce themselves in just a few seconds. Together, we are going to explore what we call the digitized world and its impact on the way we will understand and manage risk in the very near future. You all know that, over the past few years, we have seen a fantastic acceleration in themes like Internet of Things, geospatial analytics, digital twins, and we hear more and more about it. Just this year, the number of connected devices reached 10 billion. And this is accelerating. Every second, we estimate that 127 new devices connect to the internet, which means that since the very beginning of this session, more than 40,000 new devices were connected to the internet for the first time. And by the end of this session, 500,000 new devices will be connected to internet, capturing new kind of data, creating smart factories, tracking goods, helping individuals monitoring their health. And with the deployment of the 5G technology, we should just expect this number soaring. At the same time, the geospatial analytics market is living through its own paradigm shift. The cost to launch 1 kilogram in space is dropping. The number of active satellites is growing at more than 30% growth rate per year. The resolution, the type of imagery, the frequency of revisits, everything is being transformed and improving. All this new flow of data, combined with continuously increasing computing power, artificial intelligence, open opportunity for new type of data, for new type of business models, in particular, those famous digital twins. And the pandemics we are all living through have even increased the adoption rates of this kind of disruptive technologies, and it's true across all industries. So what does it mean for us? What does it change? Is it another hype that innovation geek, a bit like me, used to justify investment budgets? Or is it going one of those big turning points for our industry and many others? How does this impact the way we understand risk? How does this change the way we manage risk? How does this challenge a long-established model for insurance and reinsurance? And if everything works, which we don't know yet, what are the downside of it? Does it create new risks, challenges that we'll have to manage? It's an exciting topic, huh? So this is what we're going to discuss with our panelists today. And to start, I'll ask each of them to give a very brief introduction before we enter into the topic. And I'll start maybe by Jonathan, if you have maybe 30-second intro.
Thanks, Pierre. Hi, everyone. My name's Jonathan Salter. I'm the head of risk consulting for AXA XL. I'm based in the UK, but the team I work with is global and our clients are global. So as Pierre said, lots of interest in the Internet of Things and how we can use that from a loss prevention point of view.
Thanks, Jonathan. Laurent?
Yes, hello everyone. My name is Laurent Richem. I'm based in France. I've been working for AXA and then AXA XL for 13 years now. I'm currently the Property, Energy and Construction Chief Underwriting Officer for the APAC and Europe region. Just to give you an idea, this is more or less a $2 billion GWP portfolio, mainly composed of large corporate and mid-market clients, handled by approximately 130 underwriters spread in a dozen of producing offices. Just as a matter of interest, I would like to underline that Australia is an important one, is an important producing office for us, as it is part of the top 4 countries in our region. So I think that's all for now.
Thanks, Laurent. I'll go to Antoine, maybe.
Yes, so good afternoon and good morning. I'm based in Paris. I'm one of the co-founders of Kairos. Kairos is a geoanalytics firm. We use satellite imagery to track the status of industrial assets on a global basis. We track more than 200,000 assets today, using more than 10 constellation of satellites. There are more and more, as Pierre said. Our customers are large financial institutions, energy companies, and government. And we are a startup. We are 5 years old, but still 150 people, 100 of which are researchers. We have more than 20 PhDs and presence in Singapore, Bangalore, London, Paris, New York, and Houston.
Thanks, Antoine. Sam, over to you.
Hi, my name is Sam Whiffen. I'm the CEO and founder of Reveal. Reveal is a subsurface utility engineering firm. We basically map everything underground. That'll be pipes, geology. We do a bit of geophysics. Effectively, we create a digital twin of the underground, and we're taking this globally. Main clients are typically large state-owned enterprises, energy companies, cities, water utility asset owners, contracts. We work for large, big projects, big urban, mass rapid transport projects, where we go through and create 3D models of the underground. We've got about 35 staff, mainly based in New Zealand. Our head office is in Wellington. We've got a number of staff in the US and Australia. And yeah, do a bit of mainly work in Australia and New Zealand, but a bit of consulting all around the show, and starting to enter into the US market as well as Australia a bit more.
Thanks a lot, all of you. And Sam, let's stay on you and let's deep dive a bit into the topic and start by trying to define what we mean by digitized world. And can you explain how Reveal sees that and how it creates digital twin for underground assets? And maybe could you share your view on what a digitized world mean, and maybe illustrate your definition with some insight of what Reveal does?
Yeah, thanks heaps, Pierre, for the opportunity as well. It's interesting. The digital twin, is for those that don't know, is a digital twin of a real world asset or object. We're trying to create a digital replicant of the real world thing so that we can undertake a number of different analytics over the top of that asset. It's not just a digital model or a 3D model of that particular asset, but it has a live or temporal function associated with it, a bit of a pulse, if you will. That can be either through SCADA or IoT, or different protocols and rigor around making sure that that digital twin is as close to a mimic of the real world environment. So the underground is a bit of a challenging environment because you can't see it, and that involves a whole lot of challenges associated with that. It probably adds a bit of context, so I'll just share quickly what that looks like from our perspective. And the Reveal twin is the example that I'll show you. So what we have here is Wellington City. We have a complete and accurate model of about 20 kilometers of highway, or 20 kilometers of the main CBD of the city. When I say accurate, I mean plus or minus 50 millimeters. The intent of this 3D model is to host it so we can consume that into augmented reality. We are maintaining this through a lot of rigor around how these different assets are as built and collected. The city is a key partner in this. They want to maintain the authority of this digital underground environment. All the colors mean different things, but effectively everything's in there. We also have large concrete slabs, historical tram tracks, you name it. We've got 3D soils. And then we're doing different things around as-built-in components, like we have elements like this where we've captured with GoPro 360s and using photogrammetry to rapidly as-built different scenarios. We then harvest the different pieces of accurate data to feed back into the twin to go through and deliver that element and increase its capacity. So thought it was just relative to show what happens now, and there's a lot of stuff underneath the feet of everyone as we head into the underground world, and then trying to digitize that's a bit of a challenge. An example of the reason why we're doing this is 55% of all the assets by length in Wellington City were unknown, and these weren't on any drawings. So effectively there's double the amount of assets which is a huge risk for large construction projects or anyone working in that environment. There's no main single source of truth. So we're trying to federate all of that data, create that single source of truth so that we can kind of manage that. So there's no one really building one of these globally, and we're going to be starting to scale this across the world. It's a bit like trying to boil the ocean. We're getting a lot of challenges from people around this, but it's not really slowing us down. We've got a lot of feedback from different stakeholders globally around how important this is. And yeah, we've got a large list of different projects to get into, so we're in heavy kind of scaling mode. The reason it's a bit of a challenge is because there's so many stakeholders associated with the underground space that mimic, an organism of, you might have a city who is an asset owner, an asset operator, an asset financier, that all have completely different needs over that underground information. So pulling that into one place is a challenge in what we're after. So digital twins, it's a lot easier. There's a lot of digital twin examples of, manufacturing plant and buildings, and the connectivity of these is slightly easier because you can see the assets. But with the advent of IoT and SCADA and looking at mass analytics, we've now got an opportunity to, and by we I mean the world, look at how we benchmark and federate the data and gain far larger insights across these sorts of assets. So even the out of sight, out of mind underground world is not escaping the digital era or world. So a far cast from satellites as Anton is. So hopefully that's given a good intro.
Thanks a lot, Sam, and I think it's a very good intro and nice segue to Antoine. Antoine, your background is oil and gas as well, so a lot of underground stuff, but you kind of moved up and now focus on geospatial analytics. So maybe same question, can you share a bit more on your view on digitized world and what Kairos does? And I'm going to try to share my screen so that we can see your slides. Let me know if it works.
Yes, thank you, Pierre. So yeah, my background is oil and gas as well. And so I know the issue of modeling the subsurface. It's a complex one, extremely complex. So congrats, Sam, for what you're doing. But my view, working in energy, that I realized that even though energy is the most important industry sector for us, and in particular, for our children, due to the need to decarbonize our energy system, there was not enough, granular information to understand how the energy system was working. So my idea was to use satellite imagery to do a digital twin of all industrial assets on the global basis, industrial and energy assets, and understand what, at what percentage of capacity they were running. I mean, to understand all the functioning parameters of industrial assets on a global basis. So that's what we do. We use satellite imagery to model the world. Maybe you can go to the next slide. And as I said before, it's an enterprise business and, very R&D driven. Now, if we look at seeing that our interest for risk management, damage assessment, and underwriting, an interesting one is what we do, how we use our technology for flood monitoring. Yeah, it's a revolutionary tech because of the quality of the 3D capacity of satellite today. We can do a very high resolution 3D modeling of any place in the planet. We can add through data fusion water detection, whether it's IoT, social network, radar imagery, or optical imagery, and which gives us and using water flooding modeling, we can have a very precise view of what would be the impact of a flood, as well as real-time assessment of the damage. So it's a revolutionary technology. It has won the World Bank and the Singapore Space Challenge recently, and the accuracy was in the 90% plus, which was unknown up to now. So it's really the availability of AI and new satellite that enable us to bring this new tool to predict, assess the potential damage of floods, as well as assess the actual damages in real time. We have a couple of hours for between to be able to assess damages. We do the same with wildfire monitoring. In that case, it's a combination of soil moisture, temperature of the soil, topography, which is essential for predicting potential wildfires, wind. So from that, we can have a risk assessment of potential risk, wildfire risk. So that's one part of the equation. And the second part is to do real-time damage assessment. Obviously, this kind of technology existed before, but now it's really the next generation because of the high resolution and frequency of satellite that we can have access to. And finally, what we can also do at scale is automatic detection of building features. So roof material, vegetation on site, fully automated, high resolution, very low cost because of the cost of the imagery has dropped dramatically, which is obviously an interesting input for underwriting and risk management. So all of that are some example of what the digitalization from the of the soil. We are not looking underground. We leave that to Sam. It can help us understand our environment, assess risk, assess damages, and also as we know, the current event like flooding are much more frequent. It's very complex to use past data. It's not enough, but through modeling and having a digital twin, it enables us to really assess the risk much accurately than using just past data.
Thanks a lot, Antoine, and that's clearly fascinating, and I'm sure the audience start to see the impact it might have on the way we understand and manage risk. So maybe I'll move to Jonathan, and Jonathan, you're the head of risk consulting for AXA XL. So somehow you are on the front line. It's about understanding risk. So I know you have a couple of projects in the IoT space. So maybe can you give a quick example on what you do and how it works?
Sure, thanks, Pierre. I mean, I think it's really interesting listening to Sam and Antoine there. I think it's a really exciting time for for us to have a career in insurance and risk, and seeing all the stuff that was really kind of like sci-fi when I was growing up that we actually use now to help us make decisions and to inform clients and inform underwriters. So we heard there we've started underground, we've moved above ground, and from my point of view today, the example I was going to talk about is around property protection and prevention of loss. So you mentioned right at the start, Pierre, that there's like 10 billion connected devices. I always try and put that into context that I think the world population is about 7.5 to 8 billion people. So there's more connected devices than people on the planet at the moment. And when we talk about the Internet of Things, it's more the industrial Internet of Things that we're thinking about. So I guess we're all getting more comfortable with Ring doorbells, tracking your Amazon package, having wirelessly connected speakers, and this is a kind of personal Internet of Things, but we're thinking about the industrial Internet of Things. About 4.5, 5 years ago, we were having a number of losses at that time in warehouses. I don't know why, it just happened at that point, and we started to think about what could we put together that would help clients and would help us perhaps predict, prevent losses, and help us understand where they're coming from so we can give a bit more help to clients. So we thought about IoT in property and some of the value proposition. So clearly, if we got this right, we could have a reduced frequency and severity of claims. In terms of risk assessment, the team that I work with are fantastic. When they go to locations, we're able to help clients understand their issues and manage them, but we're only able to do that for that day a year or day every 3 years that we're able to join clients, and this would give us the opportunity to bring our expertise every day of the year. We heard Sam talking about data as well, so we need more data helps us with our underwriting assessment. And of course, from a kind of a insurance company point of view, we want to work with the clients who are risk managed and provide these innovative solutions to people. So we thought about what can we do, and we worked with a company, an independent company, to produce a digital risk engineer. So if you flick onto the next slide, Pierre, we're able there to see it's a very, very simple concept. We know that companies use devices all the time, and there's lots of data there, but they tend to use them from a point of view of running their location, running their processes, and then not necessarily bringing all of the data together to have it in one place and then put a risk engineering lens over it. So some of the examples you can see on the slide are around, boilers, pumps, temperature, pressure, the kind of the guts of running an operation. And then we can also add in supplementary sensors if necessary. So temperature, light, humidity, whatever. If there's a gap in what a client has, we can supplement that. And we can bring it all back to an IoT device, which pretty much looks like the kind of router that you have at home. It effectively listens in to a building management system. So when we're collecting the data, if we look at the next slide, we can get an idea of what kind of data we get. So we get daily outputs. So you can ask the box that we were looking at there in the center of the last slide to collect the data at certain time periods. So you get a very clear dashboard of what's happening on a daily point of view. And then, of course, you can aggregate all that data, because one of the challenges I think that we're going to face is the too much data, and what we do with that data is going to be a challenge for all of us. So we're starting to try and understand how much data do we need and how do we aggregate that. And as I said, we're able to put our risk consulting kind of lens over everything. So some of this data might be about temperature or lights or pumps, but what's that telling us? Because we know where losses come from, perhaps, and we're able to bring that lens. So if we look at the next slide, we can see one of the proof of concepts that we ran with a client looked at a large bakery. And just by installing the box, collecting the data, we were able to see things like their heating and cooling systems had perhaps not quite been configured correctly, and they were coming on at the same time in the same locations and competing against each other. They had high levels of humidity that they hadn't picked up before. They had detectors that were occasionally not working in the production cycle. And again, also they had a depth and detail of data that they hadn't been able to have before. So when we added all of this up, just over a kind of a 6-week trial at a particular location, working out maintenance costs, working out energy costs, working out the downtime that it takes to replace some of this kit or maintain this kit, very quickly they were looking at cost avoidance. So not only were we able to feel that we had a better handle on the risk engineering and perhaps the loss prevention there, but they were also getting benefits from perhaps an environmental point of view, a maintenance point of view, a cost of running, the cost of utilities. So there were multiple benefits that came out of this trial, and we turned this into our digital risk engineer product. So I said at the start there, how do we bring our expertise to work with clients every day? And we think that this is one of the ways that we can do it. But obviously, it's very much about how much data we have and how do we use that data for someone like Laurent to make better decisions.
Thanks a lot, Jonathan, and thanks to the three of you. I believe now we have a clear view on what we're talking about and what digitized world mean. And those three technologies are highly different, but to some extent they are massively working together, and we can totally see the impact that combining those three technologies together could help better managing and better understand the risk. And this is where maybe I'll ask Laurent for a quick reaction. You've been an underwriter for a couple of years now, and as a CEO for property, casualty, and energy, I'm feeling that your line of business might be the first one impacted by this technology, and this might have a huge impact on the way you do your job today. So any reaction to that, and what do you see in terms of impact on the way you guys work?
Thank you, Pierre. So my first reaction would be, wow, it's really a revolution coming now, and it will drastically change our way of doing in various areas like claims management, risk management, and as you said, underwriting. There are so many things to say, but I'm sure that through those three presentations made by Sam, Antoine, and Jonathan, everybody has understood that there are so many possibilities for us tomorrow to be looked at. So I will make two kind of statements, some high-level ones, and after maybe I will give some pragmatic examples where I see those technologies playing a role. So from a high-level perspective first, I would say that all these new technologies will contribute to strengthen the relationship between clients and insurers. Indeed, we will move from what we can call an occasional interaction, like for instance, on-site surveys made by AXA XL Risk Consulting, but also renewal discussions. So all that is rather occasional. So we will move from that to a more frequent and not to say permanent communication and interaction. So this is the first high-level statement. Then we can also say that we will move from a rather static underwriting to a dynamic one, with data being updated frequently instead of more or less once a year before renewal. And we will not only look at past and actual data, it has been said by Antoine. Really now, I'm sure we will integrate more and more predictions, like for instance, natural events, development and pattern, micro and macroeconomic drivers, but also sometimes some social aspects. So in a nutshell, the way underwriters price an account will be deeply modified compared to what is done today. And to end with those high-level statements, I think it's important to say that these new technologies will also impact deeply the underwriter's roles and skills, but I'm sure we will come back to that question later on. So now moving to very pragmatic examples. Yes, property, energy, and construction will be certainly the three lines of business which will be deeply impacted by those changes, but maybe others will come afterwards. But if we talk about property or energy, for instance, we can think about algorithms comparing estimated property insured values derived from satellite imagery, for instance, which we can compare that with what is reported in submission files. It will help to prevent potential difficult discussions when a claim occurs. We have already seen that. And it will really reinforce the trust between clients and insurers. For pricing, still for property and energy, underwriters will have more and more data to do an accurate pricing at location level in all dimensions. Risk quality, it has been said by Jonathan, but also cat exposure. The example given by Antoine regarding flood is really relevant. We can think also about machinery breakdown, thanks to the IoT. Thanks to the satellite imagery, we have a clear view of surroundings of the insured buildings. So yes, you can see that underwriters really will have a lot of information to make an accurate pricing at location level. For the construction line of business, it will be, for instance, possible to have a live follow-up of the erection of a new plant or infrastructure. It might trigger an interaction with client in case of detection of a situation which might be identified as potentially not normal. And for all line of business, I would like to raise a question. Can we imagine terms and conditions of a contract being adjusted during the life of the contract, depending on observations made through satellites or data reported via IoT? No doubt that it is a question we'll have to answer to in the very near future.
Thanks a lot, Laurent, and you did cover a lot of different aspects. Maybe Jonathan, any reaction or comment to that point from your standpoint? Anything you want to add?
So I think Laurent makes a really good point at the end there about how, what can you imagine contracts that change? I mean, I guess, listening to Laurent there, and we think about this a lot, I guess we'll end up with some kind of real-time pricing that, for example, if we think of where losses might come from traditionally, arson would be an easy one to think about, because we're talking about the ability of Antoine's team to see perhaps, I know, a pile of pallets up against a building that shouldn't be there. Okay, I know that's really basic for what you do, Antoine, but it's a nice example. Okay, and perhaps the rate changes while that's there, or if we know, for example, that someone's doing hot work and we've got the ability to see that the sprinkler system is impaired, maybe we have a different rate at that time. But the thing that I guess Pierre challenges you on a daily basis is we're talking about all of this data and all of this access to this data. And the one thing that we as insurers will have to do is change our processes as well, and be able to ingest this data, analyze this data, and make decisions from it rapidly, because there is going to be so much that we probably just can't comprehend it at the moment. And it goes back to something I think that Sam said very early on about having one version of the truth and making sure that we all have this access to the same data. But I think it is revolutionizing, and there's still it will continue to be revolutionary in terms of how we're able to assess risk, how we're able to work with clients, how we're able to bring expertise, and how we're able to make underwriting decisions from it, for sure.
Thanks, Jonathan. And maybe let's take a very concrete example for the audience. And I take the opportunity to remind everybody that you can post questions in the Q&A box. But let's look at, we've seen a lot of natural catastrophe over the past few years, increasing in between Ida in the US, in Australia. You guys had a lot of wildfire. So let's take maybe a concrete example, maybe with the floods in Germany, and see what this kind of digitized world mean to manage this kind of cat exposure. And maybe Antoine, you touched a little bit about floods. So can you elaborate a little bit on that?
So the idea of what we do is to be able to predict, the potential flood damages by doing 3D reconstruction of the terrain before the event. So, we know what are the risk areas. Most of them are not mapped in 3D with the resolution we need. And so we will acquire very high resolution satellite imagery. You to take 2 photos with a stereo, and then you can recreate the terrain. And then do modeling, so hydrologic modeling, to see what would be the impact of a flash flood or a bank flood. I mean, this is the kind of event that could happen there. So de facto you prepare, and from that you will see obvious things that can be done to protect some infrastructure, because it will be very easy to see what preventive work could be done to adapt the infrastructure of this new flooding risk that did not exist up to now. What is very interesting that by doing that, you take into account all the change in the terrain that has happened because of new building, new roads that, as we know, have a huge impact on potential flooding. So you really recreate ex ante, you model the world, and you can adapt the situation thanks to that. And then in real time, when the event arrives, you have already your 3D model, and you're ready And then you just have to acquire a few information either through satellite or social network. People say, I have water here. So you know where you have some point where you know where water is, and then you just have to adjust your model and see exactly just by moving your level depending on the fewer information you get, and you have a real picture of what's happening. And it's extremely efficient in urban areas where the traditional methodology does not work very well. So you have something that predict the damages, gives you adaptation opportunities, and then real-time damage assessment for obviously for emergency services, as well as obviously the insurance part of it. So it is, we can do that now because of the new satellite that have been launched a couple of years ago. It was, it's very recent. It's the computing power as well as the availability of data that enable us to do that at this point in time.
Thanks a lot, Antoine. That's very clear. And I don't know if Laurent or Jonathan, you guys want to react from a more insurance standpoint.
Yes. So just to continue on the European flood example, which has affected recently mainly Germany, it's completely obvious that with what has been described by Antoine, we would have benefited from a better assessment of the exposures that we have observed there, and this to the benefit of the clients and the insurance companies. Just to take a very simple example, we have seen some locations which have suffered severe flood damages. They were not identified in areas being prone to a heavy height of water. And it's true that when the flooding started, the actual height of water on the ground surface remained reasonable, but it has completely flooded basement which houses critical equipment. And this has created severe damages and consecutive PI. And I'm sure that in the future, with the support of those new technologies, and maybe also with the underground assessment, we will really prevent more, we anticipate more this type of event and the consequences of those events. And again, it will be to the benefit of the client and the insurer. From a more global point of view, yes, for sure, all those new technologies will have a deep impact on the way we assess and manage natural events. And it is key because today when we look at the loss history profile of the insurers, it is significantly impacted by natural events, and the frequency of those very large events is increasing. And we see here the influence of climate change. We all know that one of the key drivers of the impact of a natural event on a building or a group of buildings is what we call the building attributes. And thanks to the satellite imagery, but also the underground analysis, I'm pretty sure that underwriters and risk engineers will benefit in the future from an exhaustive screening of clients' insured locations, and not only focused on the major ones. And so we'll see for all those buildings, we will see there what we call building attributes, like the building shape, the construction material, are there some solar panel on the roofs, basements, again, especially when they house equipment. So really, we will improve the assessment of the risk. And let's take a last concrete example, because it really relates to Australia. With our property underwriting team in Australia, we have set up a specific process in order to better assess and manage the capacity an underwriter is keen to deploy on a given risk or client. And in that process, really, we have integrated those building attributes. Tomorrow, in a digitized world, this analysis will be fully automated and be completely exhaustive. So we will improve in that way our existing process.
Thanks a lot, Laurent. And I think we start to have a couple of questions. If you can mute yourself, Laurent. Thanks. I think we start to have a couple of questions, and maybe Iman, you want to jump in?
Yeah, thanks, Pierre. Just I suppose the first one for me is, hi, share the same sentiment when I looked at the presentations, which was wow, you know, as the former CRO of Westfield, and because I was no stranger to Nat Cat, you know, that this would be incredibly useful. But I suppose it's a question that for Laurent, who probably is expecting this question, and even though there was a reference to pricing, I think all of my risk management colleagues on this session would probably ask this as well. So let me be the first, and it is truly, whilst there is much more useful information here, is there any sense as to the extent to which your pricing models will move the dial in the client's direction in a meaningful way as a result of this absolute avalanche of good quality information?
Thank you. It's a really a fair question, and yes, an obvious one, I would say, after all what has been presented. I would like to say that the move to assess risks at location level has already started. This is not something new, but so that's why I would say that today we are already conscious that each client, and even looking at a location level, should be priced for its own merits. But it's true that tomorrow, with those new technologies, this trend will be reinforced, and the risk assessment at location level will be more and more accurate, as I said earlier in that conversation. Then, yes, each client premium will be more and more tightly correlated to its own characteristics, exposure, influence to some specific trends, be it internal or external, by the way, and will depend less and less on, I would say, averages calculated on a population of similar risk of clients. So yes, the price will be more and more tailor-made. And as a consequence of that, it might generate first more discrimination between clients with higher differences in premium, clearly. And secondly, maybe also there will be some premium fluctuation from one year to another, and or even, why not, if we talk about a real-time pricing along the insurance contract. So yes, more and more discrimination between clients, more and more differences in premium, maybe more movement from one year to another. And the last point I would like to underline, and here I come back on the question of the adaptation of our teams to those changes. It will be very important for the underwriter tomorrow, yes, to understand, to interpret all those data, to put them together in a sensible way in order to match the client needs. But what will be key, it will be the ability of the underwriter to explain to the client the various components and why the price is going in one direction or another.
Thank you. Pierre, I might just pose this question for you, and I'll leave it to you to decide who should answer it. But it's absolutely a relevant question in today's world. It says, in a world where cybersecurity is becoming increasingly concerning, how do you feel industry, that is, insured and insurers, will fare with the exchange of so much critical business activity information? Clearly more vulnerability here.
Yeah, maybe Jonathan, you want to take first stab at it, and maybe Sam, you want to add other point on all the downside that you see on with those digitized world.
Thanks, Pierre and Eamon. I think it's a really valid concern. The way I tend to think about it is that in our personal lives, we're quite happy to give away data that helps us. So, for example, we don't pay to use Google, but we pay with the data that they collect on us, but we become comfortable with that. And I think clients, in terms of businesses, will become more comfortable with data and data sharing over time. But we'll have to be able to demonstrate the necessary security and privacy of that data, and it will open up a new kind of horizon of data responsibility, probably more than what we have at the moment. And when we can demonstrate connectivity and integration and a benefit from sharing that data, so back to my Google point, we benefit from being able to use Google by sharing our data. And if we're able to price better and cover better, then clients can manage and run their businesses better through all of the benefits of this. I think people will become used to it, but I think we're some way away from that at the moment, Eamon. But Sam, do you want to add in on that?
Yeah, I mean, there's a massive risk, I suppose, and we've touched on it quite a lot. It's just the sheer volume of data that we have is going to flood in, pun not intended to the one before example, but triaging that and looking at the data, we're going to see from an IoT perspective an enormous amount of new assets that are rolled out by the manufacturers that have embedded IoT within them, and then how they'll host their own kind of IoT analytics platforms because they want to vertically integrate. So then, I can see in the insurance world trying to federate all of that data, aggregate that, make some insights across those, use those different benchmarked examples from different insurance companies. There's a huge amount of opportunity there, but the devil's in the detail around where does that data come from? What's the source? What's the, the specific attributes associated with that to make sure that we can trust the data, because there's a huge variance on what can be trustworthy or not. Cybersecurity is a massive one in terms of making sure people have that, not only the actual physical or real management of that risk, but also the perceived one of those in terms of what other stakeholders are involved with them as well. That can be just as tangible as. So there's a huge risk associated with all of that, and then with the disruptive technology, how we start to shift those different contractual requirements. It's a big challenge.
Great. Thank you. We've got a question from Simon Hardy, and given that we're coming up to the end, I might just augment the question myself. And the question from Simon is that I'm imagining from the suggestion of variable contract terms of a scenario where there is a high quality risk engineering data and real-time monitoring with variable pricing, which could peak for a particular location or part of a location for a short period of time where there is a deterioration in the risk profile. The badly cited pallet mentioned earlier, increasing the fire load is an example. To work for insurers, this would have to start with a very competitive base rate, only paying peak rates where warranted. It could help risk managers to demonstrate the benefit of managing those risks. The business case would be much more correlated. So would like to get your comments on that. And if I could just augment that question, clearly this concept of dynamic pricing, whilst in theory it looks fantastic, it may just shudder the nerves of risk managers who try to represent stability and certainty inside their organization. And I suppose I might just further augment the question, so it's really in three parts, and that is, so we're talking about dynamic pricing here. Are we potentially also moving to the area where we have dynamic coverage? And should the satellite pick up something, you get an email from your carrier to say, sorry guys, you're off. So Pierre, I'll leave it to you to decide.
And maybe, it's a great question, and I think we are all looking forward to finding an answer to that question. But maybe Laurent, Jonathan, you you want to add something on that?
No, we are. Thank you, Eamon, for that question, which is a very valid one. We are only at the, I would say, at the very beginning of all that. It is what we have in mind, but for sure we'll have to look at the positive side, but also at the downside of it. And what you have illustrated is really something that I guess no insurers would like to enter into. because we are first here to serve our clients and to ensure that they are well covered. I would more, if I take it positively, I would say that, for instance, maybe we can help clients to be better protected and not under protected. For instance, let's imagine that thanks to a satellite imagery, we detect that on a given location, there are outside of the buildings a quantity of stock which is largely higher than the usual metric or measurement we have. Then I would say here it will be our role to raise that point to the client to say, hey, dear Mr. Client, maybe you need more coverage. If now we look at an adverse situation where we detect something not normal, I guess that the first reaction would be, how can we manage that situation? And then there will be the correlation with our colleagues from risk consulting. Jonathan, maybe if you want to add on top of what I said.
No, I'd agree with what you said there, Laurent. I think it's a question that we haven't quite got our heads around yet. It's some way away. We've all said that we've got the kind of wow factor here today of what's possible, but we've still got some way to go as an industry in thinking through what we do with this and how we do it. But as Laurent said, the premise of insurance is that we're here to work with our clients and help their growth and functioning, and we don't want to get to a situation, I wouldn't think, where we're sort of declining cover all the time because of the data that we have available to us. So it's lots of questions to work our way through over the next few years as we kind of move to, as Laurent said, the underwriter of tomorrow or the risk consultant of tomorrow.
Great, thank you. Well, one of my duties as the chair of the session today is to make sure that our audience does leave on time, and with just about a minute to spare, can I just say I'd probably just close the session. And first of all, thank you, Pierre, and indeed your wonderful panelists for such an